Welcome again to GeoMath Simplified, and today we are continuing our circuit geometry series. This is the fourth theorem on our circuit geometry series. Please do well to watch theorem 1, 2, and 3 if you've not watched that, so that you can catch up with us. And just like every other theorem we've talked about on this channel, I am going to explain what the statement of this theorem means, and we are going to solve problem applying this theorem. So the statement of theorem 3 just goes as follows. In a cyclic quadrilateral, opposite angles are supplementary. To properly understand what the statement of this theorem is talking about, there are some few keywords here. Now, the theorem says in a cyclic quadrilateral, opposite angles are supplementary. So the first question that comes to mind is, what exactly is a cyclic quadrilateral? Okay, so starting from quadrilateral, a quadrilateral in mathematics is just any four-sided plane shapes. Okay, so examples of quadrilateral are your kite, your rectangles, your square. Any kind of four-sided plane shape is what we term a quadrilateral. Okay, what makes a quadrilateral cyclic? A quadrilateral becomes cyclic when its vertices are on the circumference of a circle. Now, this is what I'm talking about. I assume this is a circle, okay? So this is the circumference of the circle, the outer region of that circle. So if I place a four-sided plane shape such that the edges touch the circumference of this circle, that kind of quadrilateral is cyclic. So I can put a quadrilateral like this. Okay, so you can see that this is a four-sided plane shape, just meaning it's having four edges, 1, 2, 3, 4. And those edges, the vertices, are all lying on the circumference of this circle. That kind of quadrilateral is what we call a cyclic quadrilateral. Okay, now what are opposite angles? Opposite angles are angles directly just from each other, facing each other. So if this is an angle over here, and this is an angle over here, those angles are opposite. So this is angle A and angle B. They are opposite angles. So if this is an angle over here, the angle just directly at the other end is this angle. So this is, if I call this angle C and I call this angle D, so C and D are opposite angles. Now, what does it mean to be supplementary? What it just means is that whenever you add up these angles that are opposite to each other, they add up to 180 degrees. That is what being supplementary just means. So, if I look at this cyclic quadrilateral and I look at the opposite angles, what theorem 4 is telling me is that A plus B, they are opposite angles in a cyclic quadrilateral, they must add up to 180 degrees. They are supplementary. And also, C plus D, opposite angles of the cyclic quadrilateral, will also add up to 180 degrees. Let us look at an implication of theorem 4. Now, just like we have said, in a cyclic quadrilateral, opposite angles are supplementary. Now, this is a cyclic quadrilateral, and you can see that the opposite angle is angle A and angle B. So they are going to be supplementary. So I can conclude and say A plus B is 180 degrees. Now, take a look at angle C. You will notice that angle C is an exterior angle of this cyclic quadrilateral, meaning that it is an angle made outside of the cyclic quadrilateral. Okay? So C is an exterior angle. Now, angle C and angle B all lie on the same straight line. What do we know about the sum of angles on a straight line? We also know that those angles are also going to be supplementary, meaning they add up to 180 degrees. So I can conclude and also say B plus C is also 180 degrees. Now, given these two equations, I want to try to express one in terms of the other one. So let me just call this equation 1 and equation 2. So I can just say from equation 2, B is equal to 180 minus C. So bringing C to the other side, it carries a negative sign. Substituting this value of B into equation 1, A plus, instead of writing B now, I'll write this. So 180 minus C should be equal to 180 degrees. So A minus C equals to 180 degrees minus this 180 coming to this side becomes minus 180 degrees. A minus C is 0. Yes, 180 minus 180 is 0. And the implication is that my A is equal to C. So, what does this tell me? A is equal to C. It means that in every cyclic quadrilateral, the exterior angle is always equal to the opposite interior angle. I take that again. In every cyclic quadrilateral, the exterior angle is always equal to the opposite interior angle. Just like we have seen, C is an exterior angle and it is equal, A equals to C, it is equal to the opposite interior angle. So, whenever you are trying to solve problem using Theorem 4, you must always try to keep in mind these two things we've talked about. One, in every cyclic quadrilateral, opposite angles are supplementary. Two, the exterior angle of a cyclic quadrilateral is always equal to the opposite interior angles. So, just like every other theorem, we are going to apply the theorem we've just talked about in solving a question for further simplification of the theorem. Okay, so the question we are going to look at says obtain the lettered angle and O is the center. Okay, so O is the center of the circle. First off, what I notice is that there is a cyclic quadrilateral in that circle, so that helps. Yes. Now, since I can see that this is a cyclic quadrilateral in the circle, two things comes to mind, just like we have said previously. Opposite angles are supplementary. Exterior angle is equal to the opposite interior angle. From that second statement, immediately I notice that 66 degree is an exterior angle and it must be equal to the opposite interior angle. So 66 degree, this is the interior angle, but it must be equal to the opposite interior. So A should be equal to 66 degree from the implication of theorem 4. So A is equal to 66 degree. Okay, so A is 66 degree. And just like I have said from theorem 4, in a cyclic quadrilateral, opposite angles are supplementary. So it means that A and C, they are opposite angles and they must be supplementary. So I can say A plus C is 180. Since I know what A is, 66 plus C is 180 degrees. Okay, C is 180 minus 66. C is equal to 114 degrees. So, looking at angle B, I notice that B is the angle at the center of the circle. And just like we've said from theorem 2, you remember what theorem 2 talked about? Yes, I know you do because you are smart. Theorem 2 says that the angle at the center is twice angle at any point on the circumference provided they subtend the same arc. So it means that B will be 2 times of A because B is the angle at the center and A is the angle on this point of the circumference, and B and A subtend the same arc. So B is equal to 2A. B is equal to 2 times, where is A? Okay, 66, 132 degrees. Finally, for angle D, I notice that C, D, B, and 68 degrees also lie in a quadrilateral. Now, this is the quadrilateral I'm talking about. From this point to this point, this point to this point, this point to this point, this point to this point. That is the quadrilateral. Okay, it's a 4-sided plane shape. Okay, and the sum of angle in any n-sided plane shape, interior angle is always given as n minus 2, 180 degrees. N minus 2 times 180. So since this is 4, this will be 4 minus 2 times 180. That is 2 times 180, and that gives me 360 degrees. So the sum of interior angles should be 360 degrees, meaning B plus 68 plus C plus D should sum up to this amount, 360. So since I already have the values for C, B, and this, I can just get D by subtracting that sum from 360 degrees. So D angle D should be equal to 360 minus, what is angle C? 114 plus, what is angle B? 132 plus, what is the last one? 68. D is 360 minus, what is the sum of this angle? 314 degrees, and D should be equal to 46 degrees.